Dr. Charles Van Riper III, a USGS scientist and professor in wildlife conservation and management, and his graduate students, know that protecting a bird's breeding habitat is not enough to ensure its survival. They are out to identify all possible threats to birds, even those during wintering and migration. An innovative molecular technique enables Van Riper and his students to link breeding and migrating populations of Wilson's warblers. Called stable hydrogen isotope analysis, this technique uses atomic particles to determine what routes songbirds use to travel across the continent. Here's how it works. These are the only two stable forms, or isotopes, of hydrogen. Light hydrogen, shown here on the left, is composed of only one proton and one electron, while the less common heavy hydrogen isotope also has a neutron. Now, here's where it gets big. As clouds move inland off the ocean and towards cooler polar regions, they carry both heavy and light hydrogen. But gradually, heavy hydrogen atoms fall out as rain. Heavy hydrogen is more stable as a liquid, while light hydrogen remains a vapor. By the time clouds reach inland areas, they carry more light hydrogen than heavy hydrogen. Here, you can see how a greater ratio of heavy to light hydrogen is found in the southern and coastal areas of North America. This precipitation, with its unique ratio of hydrogen isotopes, is taken up by plants, then by the insects that feed on them, and then by birds, all of which carry this unique signature in their proteins. Because the proteins of a bird's feather remain unchanged once they are formed, we can use the isotope signature of the feathers to determine where the bird was when these feathers were grown. Now, back to the life cycle of the bird. Wilson's warblers only replace their feathers, or molt, once a year on the breeding grounds. We also know that individual birds return to breed in the same locations each year. Dr. Van Riper and his graduate student, Kristina Paxton, put these pieces together to find out where spring migrants were headed. They collected feathers during migration and compared them to feathers collected at breeding locations throughout North America. On the map, you can see in light gray where Wilson's warblers breed and in dark gray where they winter. The blue points show where feathers were collected in the breeding range, while the green points show where feathers were collected during spring migration. Here, the different isotope ratios are given different colors. On the left, you can see the percent of each isotope ratio found in the feathers at each migration station. Note that a different isotope ratio is dominant at each station. Warblers that breed along the California Sierra Nevada mountains and in the Canadian West migrate earlier and use the Colorado River during the spring. Those farther north tend to use the San Pedro River and migrate later. It seems that there is not one migratory front. Instead, there are many routes taken, depending on where a bird breeds. Natural resource scientists like Paxton and Van Riper are able to use two of the smallest atoms to shed light on bird migration in western North America, a large and long-standing mystery of the natural world.